Okay, so in our previous discussion, we looked at a situation whereby a die was tossed, right? So let's look at the situation whereby a coin has been tossed twice. Now, when you toss a coin twice and they ask you, let x be the number of times head shows up, what is the probability of x equals to 0, 1, 2? Draw the distribution. So let's say when you throw a die, what is going to be the sample space? It's either you have head, head, you have head, tail, you have tail, head, and you have tail, tail, right? And x has been defined in such a way that x represents the number of heads that shows up, right? So in the situation whereby they say probably that x is equals to 0, x is equal to 0, that means head does not show up. Then when head does not show up, it's the same as probability of having t, t. In probability of having t is only one. It was a number of tt all over number of outcomes, right? Which is because number of tt occurred only one time, and the number of outcomes is what, 4. 1, 2, 3, 4. It's okay. That is so probability of having x equals to 1 is okay. That is x equals to 1 is the same as having only one head. That is the same as probability of at or probability of what, th, and that gives what the number of outcomes is 2, and the number of outcomes is 2, right? Over total outcome is 4. Then probability of having x equals to 2. That means you have head, head, probability of head, head, which is equals to what? 1 over 4. Is that okay? Great. So this is what we have now. Great. Now, so let's do the calculate the distribution. So first, we were only asked to draw the distribution, but let's calculate it. So calculate distribution. Great. So that's, you're looking at f of x less than or equals to t, right? So we say it is. So first of all, we are going to say that it's equals to 0, right? If t is less than 0, because if it's not possible to have t less than 0, right? And the next one is it is equals to what? So let's say it's equals to 1 over 4 if t belongs to 0 with 1 not inclusive, right? We same as 0 is less than or equals to t, and then t is less than 1, right? That's what it means. So that means you have only 0, right? And the next one becomes if t belongs to 1 with 2 not inclusive, is okay. So this expression here always means the 2 is not part of it. That means we are going to have either probability of having what, 0 or 1, and the probability of having 0 is what, 1 over 4, and the probability of having 1 is what, 2 over 4. So when you add up the 2, 1 over 4 plus 2 over 4 becomes what, 3 over 4. So it becomes 3 over 4. And the next one becomes if t t belongs to 2 with infinity not inclusive. That's the same as what, x probably that 2 is less than or equals to t. The same as 2 is less than or equals to t, and t is less than infinity. So less than or equals to t, it means you have from what, 0, 1, 2. So product of having 0 is what, 1 over 4, right? So when you add up 1 over 4 plus 2 over 4 plus that will give 1 over 4 plus 3 over 4 here, right? You have 1. Or when you add up everything, you have 1. It's okay. So this is what we call the distribution, right? So let's draw. Now, because we've been asked to draw, we have probability of x here, and we have start from what, 0, 1, and 2. So probability of having anything less than 0 was what, 0. So here we have here to be 0. It's okay. And the probability of having 0 but with 1 not inclusive was what, 1 over 4. So 1 over 4 is here. So you start from here, and it ends here. And the next one is 1, and then with 2 inclusive was 3 over 4. So that also starts from here and it ends here. And the next one is 2 and up to infinity or so 1. So that also starts and goes like this. Great. So that means we've drawn the distribution. Thank you.